All right, hello Spartans. This is Coach Johnson speaking. Section 4.5a, graphing sine functions. You're probably wondering why I am not on why you can't see me on the picture, and that's really mainly because today is really probably the most important of the podcasts that I will do so far because so much rises on it. So as I talk through this, please take notes. Please make sure you get this, and if at any point you struggle with graphing, make sure that you come back and look at this so that you can refer back to it any time. All right, here we go. First things first, sine function is graphed as what is below. You'll notice that as I graph this, it will keep going on and on to the left and to the right following the same specific repetition. Now, notice that a regular sine function, a sine of theta equals, or sine of x equals y graph would end up looking like the bottom. Notice how it goes all the way up to 1. It goes down to -1. And notice that a full repetition goes from negative pi all the way to positive pi. Now you might say, well, what does that mean? Well, a full repetition is where you start and where you stop. Notice that you could do it also on these hills where you start and when you stop. But either way, a full repetition normally for a sine is going to be 2 pi. Now you might say, well, that doesn't make any difference. How do you know it's going to be 2 pi? Well, if it's negative pi to pi, that 2 pi is what we call the period of the graph. Okay? Period of the graph. It's where it makes a full repetition. That's a very important word. We're going to get to that in just a little bit. But a period is how long it makes a full repetition. How long? In a normal graph, in a sine x equals y, it will take 2 pi to complete a full repetition. Now, another word that you need to know is called amplitude. Amplitude. Sorry about that. Amplitude is the height of the sine function. Notice that in this right here, the height is at 1 and -1, but sometimes it changes a little bit. So just know amplitude is the height or how far it stretches or shrinks down. The higher the number, guess what? It's going to stretch out a little bit more. The less the number, meaning if it's a fraction like 1/2, it's going to be pushed down, kind of like stretch and shrink. Finally, our last word that we're going to look at, and we'll look at these a little bit later, is what's called a phase shift. A phase shift is what changes the graph to the left and to the right. L and R will just stand for left and right. It pushes the graph to the left and right and changes how the graph looks in that way. Now within each of these specific graphs, we're going to actually graph these here. And you'll notice that anytime I put a tick mark, that stands for negative pi. To the right is pi. And then what I'm trying to do is stretch it out a little bit so we can kind of see. So if we go over -2 pi, and 2 pi, I'm just trying to make the graph for us. It's going to go up 1, so we'll go up 2, just so we stretch it out. And obviously this is -1, -2. Now, I'll try to do a different style of graph here so we know. But the purple one is what will end up counting as our original sine function. So notice as I go up, it goes to 2 pi because, again, that's the original. Our phase shift or our period will always be, remember, I'm sorry, let's back up here. Back up. Let's do this. Back up just a hair. All right, it actually should be here. I was actually stretching it out way too far. It should end up being something that looks like this. So I go up right here, come down, okay? Come down here, 1, and come right back up. So as you could see from this point to here is 2 pi. It goes to the pi here, pi over. And obviously, as you could see, it shouldn't really be this way. It should just keep going like this. This one should hopefully come up here and keep going that way. As you can see, it's a little bit difficult, but it would keep following the same motion as if I was on the original graph. Now, on this specific one with amplitude, you'll notice that the 2 is in front of the sine graph. Anytime the 2 is in front, that stands for our amplitude. This is -2, this is the same way. So any number that's in front of that sine function is what will push it up and down. Now, in this graph, you'll notice that I'll graph this in blue compared to the purple. The purple is the original, and the blue is what we'll use as our new one. So since this first one is 2 here, what we do is we take the absolute value of our amplitude. So since it's the absolute value, we know it's 2. Therefore, we know that this is going to push this graph up, not to 1 anymore, right here. It's going to go up towards 2. So the graph is going to go down, same spot, but except now we're going to go down to 2. And I know this is kind of a bad graph, but you notice that it keeps following the same pattern. Now as I go down, you'll notice that it comes here, comes back up. Oh, so got to go up to 2, keeps going there. So my amplitude, since the number is higher, it will end up stretching it out a lot thinner. If this was 1/2, notice that no longer would it go up to 2, it only go up to 1/2. So I don't want to confuse you. Let's just say the graph would look something like, and I'm just trying to follow suit here. It should look something like right here. Boom. Something like that. Notice how it's a lot thinner, and I know it doesn't follow the specific pattern, but you get that idea. Now, going to our next one, let's look at the period. Remember, the period is how many times does this graph take to get a full repetition. Normally, remember, on a normal graph, it's going to be 2 pi. Well, in this specific case, it's going to be a little bit different. Notice, the amplitude is in front of the graph. That's our A. Our B is the value that goes with the variable, and it always follows the sine, cosine, or whatever trig function we're using. So in this specific instance, again, I'll make sure that I've got each of these taken care of. Remember, we're going to go down 2 here. Keep going to the right. Hopefully you know what that means. Remember, it goes pi in each direction. In this specific instance, to find period, we do 2 pi over b. So in this first example, what I'll do to find my period, I will do 2 pi over 4. So 2 pi over 4, as I divide, I notice that it will end up being pi over 2. So since it will be pi over 2, my period will be pi over 2. Now you might say, well, why is that important? Well, remember that any time that I have a regular phase shift, my regular period, it will always be 2 pi. In this instance, it'll be pi over 2. So every time I go to the right, it's pi. This is to the left, negative pi. And then keep going, 2 pi and negative 2 pi. Now notice it doesn't go up and down any. It still is going to go at 1 and negative 1. It's not going to go any higher or lower because there's no amplitude. Except this time, what we would normally have is a value that looked like this right here. What we would normally have is something like this. Remember where the period is 2 pi. Now what we're going to do is we're going to kick this up a notch. So let's go to black here, just so you could see it. So now from here to here, notice that that is 2 pi, or a full rotation. So now what we're going to do is we're going to take 2 pi and we're going to take it to pi over 2, which is now, if you have 2 pi and now you have pi over 2, now that's 1/4 of that. So that means that for every block here, it's going to end up having a full rotation. So instead, what's going to happen is it's going to really, really pick up a notch. So watch this. It's going to go boom. And I know this may look a little weird. But what happens now is no longer is it 2 pi. Now my period is going to be pi over 2. If I blew this up, let's just say that this was negative pi. And let's say that over here, this one would be pi. And we'll just say this is negative 1 and this is 1. Again, what I would end up doing, if this is 2 pi, I would take 1/4 of that. So where I would normally have 1 rotation on this, normally would look like this. Now what I would end up doing is having something that is 1/4 of that. So that means that every 4th spot, we're going to have 1 rotation. So it should look like this. Okay. Do this. Now, coming to the second one, we're going to look at the period. Remember, anytime we talk about period, period is always going to be 2 pi if it's just traditional. So anytime we have something with no period, the period is always going to be 2 pi. How many? We're talking about how long does it take to create a full rotation? That would be 2 pi. I guess not how long or what distance. It'd be 2 pi. So because of that, what we're going to look at now is how to find the period of a graph. Notice that this in front of the sign is always the A. Notice that there is no number. Therefore, the amplitude will always be up 1, down 1, or traditional spots. Now, since there's no amplitude up there, we know that if there's a number with a variable that follows a sine, or any trig function for that matter, we look at it and now we talk about what's called a period. Now, the period will always be labeled as our B. Notice that in this instance, B is our period, A will be our amplitude. So the B, to find our period, we always take 2B and we put it over our 2 pi and we put it over B. In this case, it's 4. So 2 pi over 4 represents pi over 2. Now you might say, well, what does that mean? Well, look at it this way. If I have a traditional graph, right, traditional sine graph, and I'm drawing that now, right, and it keeps going and going, and we know that. Notice again that a period is where it starts and stops, where it creates a full rotation. So from here to here, that is a full rotation. That distance is 2 pi. Now over in this right side, if I were to graph sine of 4x, what I would do is I would continue to go up 1 and down 1 because of the amplitude being the same. Except now what I would have to do is I would have to make sure that from 0, and again right here this is pi, I kind of stretched it out so you could see, and this is pi over 2. So from 0 to pi over 2, it would have to create a full rotation where if I took it and mirrored it, kept doing it across, it would keep creating the same specific graph. So where it starts, right here, to where it stops, obviously you can kind of see it right here. It says pi over 2. Sorry for that, it's kind of hard to see because it's so thin. But the answer, or the, in this case, period, of the full rotation is pi over 2. Now again, if I ended up having a sine to the 1/2, well, if I did 2 pi over 1/2, the answer would be 4 pi, meaning that in 4 pi, from 2 pi to negative 2 pi, if I were to do this graph, what I would end up doing is I would have something that looks like this right here, where it creates one full rotation from negative 2 pi to 2 pi. So hopefully that makes sense there. That's a little bit difficult in determining that, I know. All right, the last thing we're going to talk about is something that just kind of, it becomes a little bit different, I realize. But this is, what we're talking about now is referring to phase shift. Now, phase shift, what that is it moves the graph right to left depending upon whether, depending on what the graph is doing. So we know, first of all, that we have A, which is our amplitude, B, which represents our period, and then the BC represents our phase shift. And to solve for that, what we do is we do C over B. Again, in a traditional graph where we have sine of x equals y, notice that in this one, our traditional spot would be at 0, 0, where it crosses and it looks really nice and even, but that's not the real world all the time. Sometimes we have to find our phase shift by determining exactly what we're looking for on that. So I want you to look at this. Look at the phase shift on example 1. It says y equals sine of 2x minus pi. Well, first of all, we know that the C represents pi. So again, we're going to put pi in there, but don't worry about that negative sign. Just leave that out for right now. The B then is represented as 2. So we know that pi over 2 is what is represented for our phase shift. So because of that, as I look at this graph, I notice that my phase shift is going to the right, pi over 2. So it's going to literally move to the right, pi over 2. So again, if I'm doing this, we'll make this pi over 2. We'll make this one pi, and then we'll make this 3 pi over 2, and all I'm doing is just going every 2, and this is 2 pi. All right? Same thing on the other side, so if you know that, all it is now negative. Okay? And what we'll do is we'll make this top one 1, and this bottom one -1, and I know it's not the scale, But you get the idea. We're just trying to make sure we focus in so you can see what's going on here. Now, first of all, we've got to determine also with this 2, we've got to determine what our period is. We know that, again, our period is always 2 pi over b. In this case, it's 2, so 2 pi over 2 would end up equaling pi. So pi would end up giving us what our period is, meaning that normally we have a period from negative pi to pi, but now what we'll do is we're going to have a period from 0 to pi. 0 to pi. So it's going to be, again, a little bit different on how we actually do this. So traditionally, with the period, we'd end up having something like this, right here. Something like that. Again, coming down here. I know sometimes it gets a little bit difficult because you don't know exactly where it goes, but you get the idea. And again, these probably should be a little bit more curvy, but for sake of the tablet right now, we'll just work with it. But now we have to do our phase shift. Now again, our phase shift is taking our same graph and moving it to the right, pi over 2. So no longer will it be right here at 0, 0. We're just going to move everything over. So we're going to move everything over here. And now what we'll do is we'll just mirror the graph. So we'll go up, 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 down, up, down, so on and so forth. So over here, we're going to do the same thing to where it goes down right here. Just like so. And all we did was move the graph to the right, pi over 2. Again, that is called phase shift. Also, you want a challenge? Try this one over here on the right side. Notice that there's all 3. We have amplitude, we have period, and then we finally have phase shift. We'll put it as PS right now. All right, last but not least, let's look at this one real quick. What's our amplitude? Yep, it's 3, so it's going to go up 3 and down 3. Okay? What does that 4 represent? Well, first of all, we know that ends up referring to our B, or in this case, we call it our period, so we know it's going to be 2 pi over 4, or in this case, it'll be pi over 2. So pi over 2 will end up being what our period is. That means, again, where it creates a full rotation. And then finally, what is our phase shift? Well, remember our phase shift will end up being what is C over B. In this case, it's pi over 4. Therefore, it is going to go to the right, pi over 4. So this phase shift is going to push this thing to the right, pi over 4. Try to graph it. I know it's a little bit difficult. Try to graph it. I know that we'll refer to this a little bit more, but I know that a lot of these bring a lot of questions as well. All right, try them out tonight. If you can, come in with questions. We'll talk a lot more about this tomorrow. Have a great day.